Ladies and gentlemen, welcome back. It's time for a new session, and in this session we will dive into the fascinating world of robots. Collaborative robots, or cobots, have paved the way for automation in almost every sector, and analysts predict that they will drive growth of our sector with an expansion rate of estimated $2 billion by 2022. Now let me introduce Mr. Frank Krause, Human Factors and Ergonomics Specialist at TNO, which is Europe's third largest contract research organization, founded back in 1932 to bridge the gap between university and industry. Good afternoon, Frank.
Good afternoon.
Frank, your studies focus on the research of human-robot interaction and operator support systems, and I also know that you're working on the quality of the working environment related to cobots. Is that right?
That's absolutely correct. That's what we do.
Okay, well then, the stage is yours for your keynote.
Okay, thank you very much. Good day to all of you. I'm Frank Krause. I live in the Netherlands, and I'd like to talk to you about our Rossini project. And EMA is one of the partners in the Rossini project. And this project is all about human-robot collaboration and job quality. We're in there, TNO's in there for job quality. And the goal of Rossini is to create a human-robot collaboration, an inherently safe robot, industrial robot. So not a small collaborative robot, but a strong, powerful, quick robot, and make it inherently safe. That's the goal. But at the same time, with this robot, we want to improve job quality. And this is what my talk is about. Now, next slide. So collaborative robots. Why collaborative robots? Well, first of all, workers will not disappear. Everyone's afraid that robots will take away our jobs, but that will take a while, or it may never happen. What we see now is that jobs change. So the work will not disappear because humans have unique capabilities. We're flexible, we're creative, we have extremely fine motor skills, and these are things robots do not yet have. The other thing is, it's better to design a safe robot than to ask humans to be safe, because from history we know that humans are not always willing to act safely. So what has this got to do with job quality? Well, we want robots to make our lives better, not worse. And how can they make our lives better? Well, for one thing, robots are very good, just like machines always were, but they're very good in taking over and supporting physical tasks, heavy tasks, repetitive tasks. Like this, for instance, the palletizing robot. But these are unsafe, like a spray painting robot. Also still unsafe, but very good at taking over these tedious tasks from human beings, and that give a lot of problems as well. These are the first collaborative robots. This is the orange thing is a mobile robot that basically brings the goods to me, so I don't have to pick them up. I don't have any heavy push and pull forces. So that's positive, and it helps productivity enormous because I don't have to walk through all the aisles anymore. And this is a very new breed of collaborative robots. They're closer than this you cannot get, because you wear the collaborative robot and it supports my back when I have to lift heavy stuff. They're coming to us, these exoskeletons. That's what we research as well, by the way. So with all these technical innovations, these technical solutions, what you would think is that the effect on physical load and the physical load problems are this. Unfortunately, these improvements have not yet happened. So we still have tiring and painful positions. 2005, 2015, no difference. The same for the other loads, repetitive hand and arm movements, it's exactly the same. So my point is, how come we don't have these results with all this technology? Well, first of all, if you buy a robot, don't expect the robot to make the working conditions better, because the robots, they cannot do anything. And more importantly, it's not the robot that is designing the work. Engineers are designing the work. and they may not always pay attention to things as job quality, and that cannot be expected. Research has shown that obviously managers, they aim at productivity improvements, and they're willing to include job quality as long as it doesn't reduce productivity. Now, how do you do that? Well, that's my discipline. What my discipline is about, ergonomics. Ergonomists try to achieve both productivity and job quality. Something about system optimization, that's what we call it. Technicians tend to focus on the technical system that should be optimized, and that can be a challenge in itself. What we do is we want people to optimize the system as worker and technology. This is the system you should try to optimize, and even take one step further. We want you to optimize the full system, so worker, technology, and organization all together, because that way you will create an optimal system. By the way, this is called ergonomics, and you will create what we call sustainable productivity. So not just short-term productivity where you take misadvantage basically of the human being, but it's sustainable, and that works best according to what we think. Now, how do we treat job quality in the Rossini project? There are two ways. First of all, in the design of the cobot, in the design of the robot. And it's all about communication design, because with communication design you can achieve a lot. First of all, what you can achieve is you can achieve safety, because if I know what the robot's going to do, if the robot knows what I'm going to do, then we have a safer situation. The same goes for efficiency. If I know what the robot's going to do, I don't have to wait for the robot. If I think the robot's going to do something and it isn't doing that, then I have a problem. Same goes for trust and social. If I have a robot and I feel, well, this is I have a mate in this robot, then it helps me with my job quality. And this is another very important aspect. It's also called autonomy. That's what we all want. We want autonomy, and we want to keep control. So we don't want the robot having control. So, and this is all also about communication. So that's the design part of the robot, the inherently safe robot. We're also involved in another way, and that's in task design and task management. We created, it's still in the prototype phase, we created a design tool that helps the engineer to design the collaboration between human and robot, and not just this collaboration, but also take into account the tasks the operator is doing when he's not collaborating with a robot, because it's always you're working together with a robot, but you're also doing other stuff. And this design tool helps you to do that. How does it do that? Well, this isn't important. These are the steps. Every ergonomist starts with a task analysis. What do you have to do to build this product? And then in this design phase, you can build several task allocation scenarios. And task allocation scenarios are basically, you tell the robot, or you say, this is a task the robot will do, and this is a task that I will do. And you can build several scenarios. Then we ask the designers to score every scenario on job quality parameters. For instance, physical load, uh, cognitive load, and lastly, the tool will visualize the results. The main goal is to discuss, because that's the important thing about design phases. You have to discuss the future designs, because you cannot see it yet. You cannot see it in full, and that's why you have to discuss. So this is, for instance, a list of the tasks you have to do. This is for this is another use case, fitting a counterweight to the washing machine. Everyone knows these are very heavy, and the robot will take over this heavy lifting of the counterweight and put it on top of the machine. So you list the tasks, you list the task durations, and you assess the subtasks. That's what I just explained. Now, this is what the tool will then show you. It will show you the sequence. And if you look at the single sequence, then this has a shorter cycle time than this one. And in this case, the robot will be hand guided by the operator, and then it will let go of the load, and you will fix the counterweight to the washing machine. In this case, this case allows, however, more parallelization, as this shows. So while the human is connecting the counterweight, the robot can move back and get the next counterweight, which in the end makes it shorter. In this scenario, as I will show here, in this scenario, the physical load is a little bit higher. This is physical, and red means it's a 4. It's pretty heavy. There's still some physical load left. In this scenario, no physical load left, but there's waiting time. There's waiting time for the operator, and you don't want waiting time for the operator because it's not efficient. Wait, this here back. So basically what the tool does, it allows you to discuss different scenarios and to visualize the effects of these scenarios on, for instance, job quality. In the next phase of the Rossini project, we will test these tools in practice on the use case companies like EMA. The second tool we built, this is a use case. This is the EMA use case. Heavy reels, teabag. Alessandro will explain more about that later, and Katja. Heavy reels, the robot can do this and the human can do this. And what the process management tool does is it assigns these tasks to either the human or the robot, and it looks at several parameters. For instance, how much has the human already lifted, and what is the robot busy with? And so taking all this into account, it will assign the task to either the human or the robot. And our goal is to limit heavy lifting, to reduce waiting time, a very important factor, so to keep up productivity, maybe allow for some recovery for the operator if he's lifted a lot, and reduce exposures to risk. That's exactly what the process management tool wants to do. And this is when you're already using the robot. Now to the end, what are my key points to summarize? Cobots are our future. So they will come, and we better design them properly. If you intend to install cobots, make sure that you aim for work system optimization, not just technical system optimization. And make sure you do that early in the design phase, because in the requirements phase, you have a whole number of design alternatives and the costs of change are relatively low. But the more you get to the deployment, the cost of change will steeply rise and your number of design alternatives will go down. You don't want an advisor to tell you in this stage that you've done something wrong. You want someone to do that in this stage. Make sure you have user involvement, what we call participatory ergonomics. And if you don't have the expert in-house, get them in. That would be my advice. Thank you very much. Back to the studio.
It's us who thank you, dear Frank. Thank you very much for your very interesting keynote and for sharing your point of view with us. In the meantime, we have received 2 questions for Frank Krause. Question number 1. Frank, you still there?
Yes, I'm there.
Okay, cool. So, what kind of metrics do you use to define the job quality?
The metrics we use are from OECD, the Organization for Economic Development and OECD, Cooperation and Development. They have defined the concept job quality, and we use this concept.
All right. Then the second question is.
Can I add? It's the concept is pretty is elaborate. For instance, also job security is in job quality, and this is obviously something that we cannot influence in the project. So it's we focus on working conditions.
Okay. Next question. What will be, in your opinion, the impact of robotics in manufacturing? Tough question.
Well, it's very hard to say what the impact will be, but there is already an impact in manufacturing, an enormous impact. Look at the automotive industry. However, real collaboration in robotics, so the human really collaborating with a worker and not the robot working together with the cobot, that might take a little longer, because we're researching these things, but that can take a while. But the worker working next to the robot in a safe way, that will really go on now, I think, have a large impact.
Okay. Well, Frank, Katja, and Alessandro, thank you very much for giving us a little insight into the fascinating world of robots. We've come to the end of this session. Thanks for watching, and the next one will start in a couple of minutes, so see you then.